They say we should have known better than to fall so deep down into this rabbit hole we found. And I was thinking.
Hi, this is Nikolai, and you're listening to my dad, Rafal, co-host James Jardine, and featuring Mr. Jim Tiller on the one and only Down the Security Rabbit Hole podcast. Plug in, listen up, and enjoy.
Deep into this pool of regrettable situations. Pitch black, think back to the last time that we were happy.
Hey, good morning, good afternoon, and good evening. Welcome to, suddenly, Jim, we become sorcerers. I don't know what just happened. Welcome down the Security Rabbit Hole to another edition of the Down the Security Rabbit Hole podcast. This is Raph, my co-host underneath me there, Mr. Jim. How are you, sir?
I'm doing great, and I gotta tell you, this is going to be one of the toughest shows for me to keep my mouth shut because I'm so passionate about this topic on so many levels. Literally, I'm going to be having to zip my mouth open and close over and over again just to kind of make sure I don't step over everything. And I'm already doing it, even in the introduction.
That's all right. That's all right. This is perfect. I love it when I get excited about a show. I got to give a hat tip to my old buddy. No, he's younger than me, but my old boss, Jason Clark, who hooked me up with this one. We have a great show today. We're going to talk a little bit about an application of AI that I think may be the first time where I can say, like, hey, that actually makes sense. Judging by my LinkedIn posts, if you guys follow me on LinkedIn, you know I'm not exactly the AI will take over the world guy, but this may be a good one. So first and foremost, Shiran Bareli, please introduce yourself. Let us know who you are, what you do.
Hi, Rafal. Hi, Jim. It's such a pleasure to be here. So I'm Shiran. I'm here. I live here in Tel Aviv, and I'm head of research at Cyera. My background, I came from the famous unit of 8200, which I was fortunate to serve in for 9 years. I was there in the cyber division. Yeah, long time.
That's a long time, actually. Yeah.
It's a long time, and it was, I think, one of the best periods of my life. I think that I did amazing stuff. And that's my background. I came from the combination of, I wanted to say AI, but it was more like machine learning. We called it machine learning back then. AI is a new phrase that we're using today. The combination of machine learning and data analysis with cybersecurity, offensive and defensive, of course. And that's my, let's say, the biggest part of my background. After that, I was released, I worked as a security manager, research security manager at Imperva in the field of web
I know those guys too.
Yep.
Yeah, I worked on WAF, web application firewall, and web application security. I did that for a couple of times, and then I joined Cyera, joining my friends Yotam and Tamar, which we served chair by chair for 2 years. They started Cyera, and I was lucky to be there from the beginning of the way, establishing the research department.
That's awesome.
Today, what I'm doing here at Cyera today, I lead the research department, which is responsible. We are responsible for the security content of Cyera, which is a data security platform, and also the data classification and all the AI models and data and all the data related in the company. So that's what we do.
So look, let's dive right into it. This notion that security starts with knowing your data, and because that's the currency, right? That's what hackers go after. They go after the currency, which is the important stuff, which is the data itself. That said, and Jim, you and I can reminisce and cry over this because I can see the smile. In the last 25 plus years, that is the part that we have done the absolute worst job at. And it became like one of those, it became a joke. Like, oh, can't identify your data? That's okay. Just put random controls around everything and hope that it works. And that has been my career in cyber, honestly, is it's felt like. Shiran, tell me why it's so, from your perspective, why it's so gosh darn difficult to identify, to like make sense of all this data that we're producing, this currency of the digital age.
So first of all, you said it, data is everything. It's the foundation of what we are as cyber experts and security experts. That's what we're trying to protect. This is the main asset of every company. But data has like lots of faces. Data can be PII and PCI and PHI, which are more regulatory related classifications, but it's also the intellectual property. So you can't use one tool for everything. And also, let's think about the most simple example. PII is something that since GDPR started to take place 9 years ago, something like that, 2016, and other privacy regulation in the States and in all over the world, the company started to pay attention to PII, to personal identifiable information. But not all PII is equal. Of course, employees' PII, those are important as well, but they are not as important as protecting your customers' PII. Sure. So the context here has lots of meaning in the context of what we're trying to defend and to secure. Why was it so hard? Precision is the key. This is I think the main word that we need to discuss here. Because we have lots of data, and when we have this discussion with customers, we hear it a lot. I mean, when we're talking about 90% precision, which is pretty good for, let's say, all generation models, most of the DLP tools did not have this kind of precision. But even if they do, 10% of false positive, when you're talking about terabytes and petabytes of data, it's huge. I mean, it's a huge mess. It's and depending, yes. So security experts don't want to hear this noise. So this is one thing. So the precision is a big issue there. And the other aspect is context, is understanding the context of the data. Like I said before, not all data is created equal. So those are, I think, two main issues there. And I think that the third one is what we're about to talk about today, the technology. The technology is changing all the time, but sometimes it's even it's indescribable to understand where we were 10 years ago. 2012 was the first steps of deep learning and NLP. NLP back then was something else completely. So when we're talking about the tools that they use at that point of time, we're talking about regexes mainly. Regexes and heuristic rules, which are basically not good enough to understand context.
That's a very polite way of putting it.
Yeah, that's a very nice way of putting it.
They're just not good enough.
I can give you the Israeli approach, but it's rougher. So I'm trying to adjust to the crowd.
I like it. So go ahead, Jim.
I was just going to say is that I like how you sort of framed it, and what I find, and we can get into this later when we talk more about ML AI kind of scenarios, which I'm really looking forward to having that element. But what we do have is we all keep talking about how information keeps expanding like rapidly and exponentially, right? And the irony is, large language models and things like that properly applied, it actually works to your advantage in some cases, right? And so that you can see this way of how AI can actually close this massive gap. If we had, in my point earlier is, before we started recording, is think of like a Venn diagram, right? You've got your controls and you got your threats, you got your assets, and this is growing and we have no control over, we don't know what we're doing, right? And so we're just wrapping controls around everything. But as we look at what information is, we can begin to start having that context that you started building, that sort of comment that you started on. And the fact that you're using terms and you're expressing these things, these are all like objectives. We're trying to get to that point, right? And it's really hard. And then I just want to add one more little dynamic, just to add to your point, 2 cent add to you, was the valuation of information has a life cycle. And we learned a lot about this during a lot of the ransomware attacks. And so there were decisions being made. It's like, well, is that information really valuable? Does it really expose us? Does it really that? So when we talk about things like PII and stuff like that, even doing the basics sometimes is hard. Does it have a social security number plus this or whatever? But I think the demand for having greater sophistication has reached a pinnacle. And I'm hoping that we're seeing an evolution of technology in the ML space that can get us there. But it is, in my opinion, when it comes to security, it is probably one of the largest major issues out there, hands down, 100%.
I want to add to what you said, Jim. When we're talking about sensitive data, the main question that we should ask ourselves is sensitive by who? Who tells you what is sensitive data? So I think that we have two kinds of personas here. The first one is the regulator. Like I said before, we need to be compliant. We need to follow compliances. It can be GDPR, CCPA, if it's health related or credit card related or stuff like that, financial related or stuff like that. The second one is the company itself, is the data owner. As a company, I have the data that is sensitive for me. For example, if I'm Pfizer, the COVID vaccine was very sensitive 3 years ago, something like that. And if I'm a company that I don't know, that I have like a Coca-Cola, the Coca-Cola recipe is super sensitive, and this thing cannot be predefined. And that was a major gap between the technology that we had 10 years ago and the technology that we have today. We can adapt it and we can create what we are calling in Cyera learned classification much more easily than we could do it before.
So, look, yes, the problem continues to expand, Jim, and I think we've probably covered this. I was quickly looking through the podcast history. We've talked about data a bunch of times. We've talked about the catastrophic failure that was DLP, all the attempts at it, right? Because what those efforts created was significantly more noise than anybody could do anything about. And that was the biggest problem, because the question of where's the data became here, wait, no, there, and then it became everywhere.
Yeah.
And so that's why we started putting security around like everything, because, well, it could be on that workstation and that tape drive and that laptop and that and that and that and that. And suddenly it's impossible to do anything with it. But the alternative was to, like, I remember when I was at GE and we did it was called a data classification project, data protection classification project. It was supposed to be like a 6-week project where every owner of a department had to go through all the shared drives that they had that were belonged to them and tell us what kind of, like, which level data it was and the owner of who's responsible for it. Well, you know how that went, right? I don't have to tell you anybody how that went. Like that short project turned into like a multi-year, never-ending cavalcade of, oh my God, what are we even doing here? And it was worse because humans trying to read something, go through a directory and go, oh man, is that level 2 or level 3? It's got a customer name in it. But like that is done at this, like a sloth was doing that. Computers can do it faster, but the problem that I had with computers at the time, and even up until very recently doing that job, was like the whole reasoning part wasn't there. It was like, oh, that is a ABC, AB, ABCD. That's a social security number. Like, well, not really. and you know, like if you lost a machine, or if a computer got compromised, or an account was compromised, or an email address got compromised, like what was in it and how important is it to us, and can we get it back, or is it nobody could answer those questions. So tell me how AI is changing that, because that's what you guys are all about, right? Your whole perspective is AI is going to make this better. Tell me how.
Yeah. So how? LLM is the answer. Shortly, LLM is the answer. And what do I mean by that? What the technology that large language models provided us is the ability to look at the context of a document. Let's stay for a second in the unstructured documents problem. Of course, not every 9-digit number is an SSN. And you have like the structure, you can filter out all of the stuff that is not SSN, that are not SSNs. If it's longer or if it looks synthetic, for example, 1, 2, 3, 4, 5, 6, and so on and so on. But once you got to a point that you recognized a data entity that looks like something similar to what you're looking for, in most cases, it won't be enough because you want to understand the concept, the context around it. And the context, it's not only that the letters SSN will be written before that, because this is what the large language model brought us. It doesn't have to be SSN dot and the number. It can be like my SSN number is, or I will write you my SSN number after I will finish the recording, and then the number will appear. So the ability to understand text and to understand natural language, this was the big step forward that AI brought us to. But in the same sentence, I will say that by itself it's not enough. In order to get to a good data classification in precision and in scale, you need to have like a compound AI system. And what do I mean by that? You need to use multiple tools and multiple technologies in order to get to the same point. Like we said, LLM is one tool, but also statistical validation shouldn't be forgotten. And regexes, which we all love to hate, we can't just throw it away. It's the foundation. We need to filter data by regexes. We need to do statistical validation around that. We need to use other methods that are not only NLP and LLM to be able to understand data correctly. We need to look at the context. It's not enough to look at the document itself. What is the drive that it's saved in? Who is its creator and the owner? And I think that looking at it as like a compound problem, a holistic problem that takes into consideration multiple features and not only one feature, that's what AI brought to the table.
It's creating that picture of weighted characteristics. So, and you look at how much it gravitates toward the center, you can make a more informed decision by bringing in these characteristics. And some may be very distant in that map, where some may be very close and higher valued. And we kind of laugh about things like regex and stuff like that, but I think to the point is we have to go in this direction because the technology has ultimately failed. It hasn't kept pace with the volume and types of data. And so when you look at it through that lens, I believe, kind of, if I'm interpreting you correctly, it's the ability to understand these different relationships and weight them or evaluate them in such a way that gives you a greater confidence that this is happening. Because I could argue that because of decades of false positives, it's given birth to all these things like, EDRs and people saying, identity is the new perimeter kind of thing. These are all things to get closer to the data in a more isolated way, right? Which has been countered by the cloud kind of thing. But is that a good summation is that a good interpretation of what you're saying, is that it's taking a lot of different things organically and then using that to make a decision?
Yeah, definitely. I think that then when we're talking about not only AI, but also machine learning, and I think that a new approach to classify data. It's exactly what you said. We need to look at the relationship between things and not only on one parameter, like to analyze the specific data entity or the specific regex or the specific sentence, but looking on it as something that is much more holistic. Data is not like in most cases the data points are related to the environment that they are saved in, and even if they are not, it's also something meaningful. For example, if you'll see an HR document in a drive or a folder that is not related to HR, it also means something. So I think, like you said, it's all connected somehow. And when we're talking about how AI helps us to get conclusions out of it, AI helps us to understand the connections, even if we can't really predefine them.
Do you envision a world where data classification becomes more shades of gray as opposed to it fits cleanly in these buckets because of what you're saying?
We are already there. Today, it's definitely shades of gray. I can explain how our models work, but it will be like only 70% that I can really explain, because it's neural network. We don't really know how most of it works. So yeah, it's there is some unknown in the process, but like I said before, we need to use it wisely. We can't, for example, one thing that always people ask me is, why not just use ChatGPT or similar? Just ask what kind of data entities is in this document. So there are a few answers for that. The first one is, it's super expensive. It will cost you like millions of dollars. And even if it wasn't, hallucination is still a huge problem when we're talking about AI and the world of LLMs. So we really need to create some safeguards around that, to make sure that it will not happen.
Okay, so can I ask the question that I've been thinking the entire time since you started talking about like why AI? Everything I know about how AI works is you get an algorithm and then you train it on some data to then use that neural network that it's built to do other things. How do you do that when you're talking about personal data and stuff that you want to keep secret? Like, do you just have a giant pool of social security numbers somewhere? You're like, aha, or I can just to be maybe a little funny about it, like all those compromised databases out there, pools of stolen data. Is that how you guys try? I mean, I don't want to know the secrets, but like, really, how does that work? Because you can't do it synthetically.
Okay, that's a great question. So two methods that we use. First one is what we're calling supervised learning. Exactly what you said, and it's based on lots of things. One of them is customer feedback. And second thing is that we are using soft labels. What do we mean by soft labels? I don't need to tag or label the data by myself, but I can use the machine to label the data. In this case, I don't really have to have the data on my end. And this is kind of, it's interesting to discuss that, because the knowledge is out there. This is what large language models are, because large language models are trained on, I don't know, trillions of petas of data. So they really know what they're talking about, and they are accurate in some point. And when you have like the right prompt engineering, and like I said before, the safeguards, it can really help you to create what we're calling in Cyera soft label. Because I'm not asking the LLM, please classify this document of, I don't know, 1,000 words. I'm looking for the data entities, the specific data entities, and then I, let's say, we conquer the problem a bit. This is one thing, but I think that the other thing is also using AI for a bit more complex problems than recognizing PII, which recognizing PII, I'm not saying that it's easy, because it's not. If it was easy, everybody would have done it like years before. But when I'm talking about learned classification, what is learned classification? Something that is not supervised, it's not predefined. For example, the ability to classify proprietary data. And the way that we're doing that is we are training a model, an LLM, an open source LLM, for this specific task, to classify a document by the way we classify our documents. And the way we have like lots of documents and we give them, like I said before, the soft labels. And then I can show the model, I would classify this document as recipe, this document as an invoice, this document as, I don't know, license agreement and stuff like that. And then the model understands the task. And I think that this is what we're talking about how AI works. This is the foundation of that. We train the model to think like the human thing. Hope it answered the question.
Yes, it gives me some insight, because I immediately think, okay, we some of the AI that I've played with, you feed it a bunch of real data so that it can then understand. You give it the summary knowledge of a bunch of books, that when you ask to summarize the book, it's got some context. But I imagine that, I'm trying to wrap my head around how I would do that from stuff that's actually secret. The follow-up to this is, are we finally maybe almost at a point where if an executive's email mailbox gets compromised, I can look at, or I can ask a platform, I can ask your AI maybe, hey, is there anything in there that we, the company, need to be concerned about? Like, are we there? Are we almost there?
We're there, 100% there. Yeah.
Really?
That's bold.
Yeah.
Really?
Mm-hmm.
That's a bold. Okay, so that's a bold claim.
That's bold.
How do you do that without violating somebody's privacy? Like, maybe they have emails with their doctors and stuff.
Okay, so first of all, we are there from the technological capability. We need the company's agreement to do so, to run on emails. This is not something that is you can take for granted that it will be possible. But how does it work? So we are talking about, when we're thinking about emails, as long as we have access to all the emails that were sent or are in the inbox, then it shouldn't be a problem, because the way that the model works is classifying the email as an entity, as an object, let's say. And the object gets a classification. We're looking for data entities like PIIs, which will be amazingly noisy if you look for PII in a CEO's or any person email, because there are plenty of PIIs there. I mean, in every email you have a PII, which is your email address, and sometimes the phone number. But if you look for something more interesting than that, like the combination, we call it in Cyera toxic combinations, like the combination of multiple PIIs with like a real sensitive data, like PII with financial data, someone's credit card number with his phone number, or bank account and SSN. This is something that is more interesting to show. And also the ability to classify the object.
Huh. I'm thinking that through.
I'll give you an example. Sensitive data can be, for example, I get to my mailbox once I hire someone. I get to my mailbox the employee agreement signed. This is a great example for a very, very sensitive email, right? Because it contains lots of personal data on this person, his salary, his full details, bank account maybe. You wouldn't have the understanding of this is being a sensitive email if we only classified the PII in that. Because if I would say there is a full name there, address, phone number, employer name, that's not that sensitive. But the way I give you the context, this is an employment agreement that was signed in the last year, let's say, then it becomes, oh, this one is an important one. Once I can say it's of an employee or a candidate, which in some cases is much more sensitive. Candidates PII is more sensitive than employees PII because of the regulation. As an employer, you need to, you can't keep your candidate's PII more than 90 days or something like that.
Imagine what I find interesting is when these types of conversations is we all understand there's things that need to fall into place to support the technology capability that exists that you're saying as an example. But what I find fascinating specifically to Raf's question is with an intelligent visualization, I can go to an executive and say, here's the vastness and representation of the importance of your email. So I'm sorry, but you're not going to be able to use that silly little computer that you want to use when you're in the Bahamas or whatever, right? Yes, you have to multi-factor authenticate. And here's why. So you can either delete all your email or you can just take these extra security steps to protect it, right? So a lot of times we only ask that question after the fact. Now we can project it into the future. And I think that's a huge difference.
Wait, hold the phone. Does that mean, Jim, that we can actually do purposeful security? Is that what I'm maybe hearing?
It might be like, doing security stuff or like a real risk assessment, or the accurate application of security controls in a balanced and an adjusted scenario. I don't know, crazy things.
I must add to that. It's not only emails. Emails is one example. I think more interesting one is looking at identity and who can access data. For example, let's talk about M365 or Google Drive. It will be a very important view to see the top 10 identities that get access to most of the data in the company or most of the sensitive data classes in the company. And you would be surprised what you'll see there, because there will be there, I assume, the admins, which is not surprising, right? That the admin will have access to multiple kinds of data. But you would be surprised that some, role that you defined or a group that someone defined 5 years ago grants access to a specific team in the engineering that allows them to get access to production data that they shouldn't access.
100%. And that's very difficult to do without data classification.
Yeah, it's impossible to do with data classification, and I will add and say that it's data classification by itself is not enough. It's not enough. Everybody knows that they have sensitive data. So what? I have sensitive data. What do you want me to do with that? So if I can point the top 10 identities that get access to this data, to the most sensitive data, or if I can point out the non-human roles, for example, or services in IS that can grant access to this data, this becomes much more interesting. You want to make sure that you have multi-factor authentication for those entities, or that you reduce the amount of human identities that can access non-human identities that have access to, like, let's say, major systems that contain very sensitive data.
I'm over here kind of quietly processing this because I want to get really excited. I like, part of me is just super excited. But I have to say, like, I've seen this promise before, and it didn't work out so well. So is this being, like, are you guys using this in real life?
What I discussed about the identity, yes.
Yeah. Okay. So because look, I think there is no greater danger to any organization than its ability to control the access to its shared drives and data, right? One person, this has happened. I've done this. In fact, I did this week. I created a share. It was supposed to be for me and the team that's going out to a customer to put our notes in. Well, the salesperson wanted access and their manager wanted access just to see what was in what you guys are talking about. Fine. And then like suddenly we were adding, there's nine or 10 people in, and then I'm looking through this. It's like, these, access requests. And I'm like, I don't know these people. This is really sensitive stuff. So now I'm getting complaints that like, we're withholding access to critical data about a customer to people who need to see it. I'm like, I don't know these people. How do I vet this? And by the way, people we're all throwing stuff in there. Hey, screen capture of the whiteboard that we just did. Hey, this email this person just sent. Hey, let me, put that into a PDF so we can all see it. And like, before you know it, there's a mountain of stuff. I don't know who's actually accessing it, and if or who has access to it, what they could do to it, and there's no way to control this. So if you're telling me there's finally a way to start making sense of that, hallelujah.
Hallelujah, right. And think about this is, I call it the policing kind of conundrum, right? So security people who are in the trenches getting the work done, and people that are dealing with things that RAF is dealing with, is you're put in a position to sort of police the data, and all of a sudden you're the bad guy, right? Oh, you're not letting me access to this. Next thing you know, emails are flying to the CEO, and it's a train wreck. But if something can say, okay, well, here is the sort of importance or criticality or value of that data, you can then also extend that into those identities and saying almost like rights and sort of classify risky, lesser risky, or different types of users. I don't know if that's possible, but I know Cyera does the identity piece, which is pretty cool. So I think even today, going into like Azure and trying to find out where any group is assigned to any policy or any system, that's actually quite difficult. You have to write, PowerShell script or code to get that to happen, right? There's really no easy way to do that today. So
yeah, it's impossible to do it manually.
Yeah,
it's impossible to do it manually. The problem with cloud is it's overwhelming. The amount of data, the amount of roles, the amount of users, it is unimaginable. You can't use it. You can't do it manually. You can't know for sure if someone asks you to get access to a specific document. You can't, if you don't know him personally, you can't know what access he should or shouldn't get. And this is where data classification kicks in, because if they're asking, for example, I mentioned before, Coca-Cola recipe. If they have like the access to what other products Coca-Cola has, I don't know, Pepsi, no, it's a different company, or Sprite recipe, then maybe you should have access to that as well. Maybe it makes sense. Maybe it's from the proper R&D department. Or if a manager requires access to an HR salary cycle document. If he has access to all the others, it makes sense that he will have the access to this one as well. It makes decision easy. And I think this is all about AI, right? Making our decision easy, because we don't want AI to make the decision for us. We want the AI to help us to make the decision.
Thank you for saying that.
In a much easier way.
Thank you for saying that, because there's too many people out there that are evangelizing with their shenanigans of just simply eliminating the human out of the loop, and I feel like that's a path to ruin. It's just not a good idea, in my opinion. So, all right, we are unfortunately a little bit over, but definitely out of time. This has been a great conversation. I think that being able to effectively identify, classify, and I mean, hell, just identify, right? And tell me where my data is, who has access to it, what's being done with it. That gives me so much more confidence in the security posture of the company and the way that I apply security principles. I think if this type of technology starts to get adopted more widely, we could potentially start looking at dare I say, a wave of change in how we do security. Jim, is that even possible?
Yeah, 100%. You took the words out of my mouth. There's a lot of people talking about AI doing all kinds of crazy things in various areas. And even if you just whittle that down to the security industry, people are throwing AI around like crazy. In my humble opinion, this is the only space that actually is going to make a tangible and monumental change to our ability to actually secure information, right? So you can AI your way in through a lot of stuff, but applying in this area, because it has that, you can synthesize it very obviously with what the human is trying to do without exposing the human to being replaced. It's the perfect application of AI in the security sector, in my opinion.
All right. Well, that's a great place to end it. Shiran, thank you so much for being on the show. Folks, thanks for listening.
Thank you for hosting me.
Yep. And we will catch you guys another time, another place. We'll continue this conversation at some point in the very near future on another Down to Security Rabbit Hole podcast. Thanks for listening. We'll catch you guys later. Bye-bye then.